Let's look at order statistics. We have a string of 20 Christmas lights. When one bulb goes out, the whole string goes out. The lifespan of each bulb has an exponential distribution with mean 500 hours. Find the probability that the string lasts more than 100 hours. Let x1, x2, x3, x sub 20 be the lifespan of each bulb. Let's arrange these in order and call them y sub I, so that y1 is less than y2 is less than y3, is less than y20. In other words, the 20 values of y sub I are exactly the same as the 20 values of x sub I, but the y sub I are in order, and the x sub I are not necessarily in order. The string goes out when the first bulb goes out, so we need to focus on y1, which is the minimum of the x sub i's, because we don't care when the second bulb goes out. That's irrelevant. We want to know when that first bulb goes out. Let's find the PDF of y1 that is. Essentially, this is the PDF of the whole string, because when that first bulb goes out, it's all over. They're all out. More generally, y1 is the minimum of the x sub i's, and y sub n, that's the maximum of x1, x2, x sub n. Now let's say the PDF of y1 is g1 of y, and the PDF of capital Y sub n is g sub n of y. The corresponding CDF for each would be capital G1 of y and capital Gn of y. So it turns out that the PDF for the maximum is g sub n of y. It's n f of y to the n minus 1 f of y. In other words, n capital F of y and to the n minus 1 little f of y. And the PDF for the minimum is g sub 1 of y equals n times the quantity 1 minus capital F of y to the n minus 1 all times f of y. So the PDF for the minimum is g sub 1 of y. That's n times 1 minus f of y to the n minus 1 f of y. In this case, f of y has an exponential distribution. So you can write it as 1 over theta e to the negative y over theta. In other words, it's 1 over 500 e to the negative y over 500, where y ranges from 0 to infinity. And so capital F of y is going to be 1 minus e to the negative y over 500, because that's the antiderivative, and you can get that just by taking the integral of 1 over 500 e to the negative y over 500. We've done that before. Okay, so g sub 1 of y is n times 1 minus capital F, that's that CDF, 1 minus capital F of y to the n minus 1 times f of y. In other words, it's 20 times 1 minus e to the negative y over 500 raised to the 19th times 1 over 500 e to the negative y over 500. Okay, 1 minus those cancel, and we're left with 20 e to the negative y over 500 to the 19th times 1 over 500 e to the negative y over 500. Okay, so you can move the 20 to the other side and combine the e to the negative y over 500s. And we're left with e to the negative y over 500 to the 20th times 20 over 500, which in other words is e to the negative 20y over 500 times 1 over 25, or it's 1 over 25 e to the negative y over 25. Notice that this is an exponential distribution with mean 25. So the PDF of this string, in other words, the PDF of the min, it turns out to be an exponential distribution as well. Now let's find the probability that the string lasts more than 100 hours. The probability that y1, the min, is greater than 100 is the integral from 100 to infinity of g sub 1 of y dy. So in other words, it's the integral of 1/25th e to the negative x over 25. You can hardly see it, but that's a little negative sign there. And that's when you take the integral 1/25th e to the negative x over 25 all over negative 1 over 25, plug in 100 and infinity, and well, these things cancel, the 1/25ths. And you're left with negative e to the negative x over 25, 100 to infinity. Plug in infinity, you get nothing. Plug in 100, and you get negative e to the negative 100 over 25, which is e to the negative 4, which is about 0.0183.